All right, welcome to the week 5 project. You guys ready to get started? Here we go. Here's week 5 project. Here's some of the things we're going to be doing for week 5 project. We're going to be calculating or constructing a 9% confidence interval for both schools, private and public, for both schools for the private proportion of it. To do that, we have to actually know what how many is private, right? Things like that. Also, we're going to be doing a 95% confidence interval for the mean of annual ROI. Let's get started. See here. All right, so we have our question template here. I'm going to move it over. You can actually do it insert and then go to text and all that to get it in there over here. So the first thing I'm going to do is go ahead and copy the question over here. All right. Just copied it from the site. So what we're going to do is construct a 90% confidence interval for the proportion of schools that are private. Okay, so we have to know what schools are private. Okay, this 90% interval for this. Let's see here what we have to work with. So one of the first things we're going to be getting for this information is we want to know some characteristics of our sample size first. Now, what is our sample size? Well, from here, we have a total of 20. Okay. What I'm going to do is go ahead and run the actual insert function and pivot table just to get some of the statistics for us, just basic stuff, right, that we need to know for the counts. Okay. And what we're going to do is we'll just put it over here in the corner here, out of the way. And what I wanted to do was make sure we select on the school type, and then I'm going to drag over school type underneath the value calculations. And when I'm going to go a step further, once we do this, we'll know 16 right here. So we're going to take a total of 20. So 20 is the total sample size. Response interest is going to be the private, which is what we talked about, right? Private. 16 is the count over here, which is right there. And the sample proportion is basically what is that divided by that. So we can actually take equals this divided by that. And notice is up here too. And that's all we needed to do, right? We could have gotten this real fast by going through the values tab, show value as, and do it percentage of grand total, I think. And then you can do that too, like that. Either way, this is just more of a quick thing to help you. So, and I'm going to go ahead and make this, there you go. So that's the first piece we need. The second piece we need to grab is we're going to be building the confidence interval and the z-value, confidence coefficient, the z-value. We're going to be doing also the standard error and the standard margin. So, okay. So what's confidence coefficient? Well, we already said that we're going to do a 90% confidence interval, right? We're trying to get that, right? So that's our confidence coefficient. Okay. Now to get a z-value, you remember you can look up the z-value, right? If you wanted to. Or you can actually use this formula called equals norm, like normal distribution, S dist. So standard normal distribution. Okay. If you're going to use the older Excel, you're going to use normal S dist. Either way, dot S dist, or normal S dist. Depends on what version of Excel you have. That's why you have those little exclamation points here telling you. So this is what you want right here. Returns on standard normal distribution. So you double click on here. Now it's going to ask you what the z-value is. Okay. So we're looking at so we're going to take the 0.5, let's see here, okay, plus, let's see, your confidence coefficient divided by 2, because of 2, right? There's 2 in there. You want the average of that. And basically why you use half is the largest value you can get of the data, right? So you push enter. Make sure it's right. It should be right. Oh, I did inverse. Wrong. It's supposed to be S inverse. Let me see if I can get it in inverse. That's the one you wanted, sorry. So it returns the inverse of the standard normal. That's what we wanted. The mean of 0. Okay. So this is exactly what you want. So if you see that up here, S or normal.S.inverse, excuse me, 0.5 plus the confidence coefficient divided by 2, and then you get your Z value. Okay. Now again, if you want to, like me, I want to just use the first 3. You can just adjust it here if you want. So that's your Z value right there. And you can use this calculation anytime you need your Z value, okay? Or you can look it up in a table. So either way. Next thing we're going to do is the standard error. And the way that is basically used is you're going to do the square root, okay? So S equals SQ, and you see right there it says square root. And then it's going to then basically you put in your numbers you want to square root, right? So for example, I want to take the square root of the sample proportion, okay? I want to multiply that factor, and I want to open up a bracket here, okay? I want to do 1 minus the same factor, all right, which is the proportion, sample proportion, right? And I want to close that bracket, and I want to divide this by the actual, let's see here, sample size, okay? And you close those brackets, and then you push enter. That's our standard error. So if I wanted to have the same value there, like the percentage or the format, I can do that. So 0.089 standard error. That's our error, okay, we're getting. Now the margin of error, you can actually use the standard error. So you're taking basically your standard or your Z value times your standard error. Okay, let's do that real quick. Equals the Z value times the standard error. And you push enter. Now that's how you get that factor in there. Okay. Next thing we got to actually build is the estimate. This is exactly what we're supposed to be building in the first place here. The question 1, right? All right. So how do we get this? So your point estimate is equal to the sample proportion, which is that. So I'm going to go ahead and push equals. Click on the sample proportion and put it in there. So that's the point estimate. To get the actual lower and upper limit, we actually need to use the actual point estimate, and you subtract your margin of error. So we do that right by doing this. Equals that minus the margin of error equals point estimate you add it, now you add it for the upper, excuse me. You add it for the upper. Point estimate plus the margin of error. So now you get this values here. So your question is, how do you interpret your results? Well, something like this you can say. And you can change your words however you like. Okay. What I'm going to do is move this so you can see it. Okay, there you go. Basically, we're saying that we're confident that the average population proportion of the school being private for business major is between 6.52 and 9.47%. Okay? Meaning that your annual ROI is going to be between 6.52 and 9.47%. We're 90% confident because we gave it a 90% coefficient. If we wanted to change the coefficient to 0.99, see what happens. Now your limit is going to be, when you put it at 99% confident, you're going to have it between 5.7 and that, right? That's the values, right? So, but right now we're not. We said 90, okay? So I'll change mine back so you can see it. 0.9, boom, 90. So you do that for both, okay? So the next thing we're going to be doing, this is the first question, right? The next thing we're going to be doing is, we want to remove this stuff, is we're going to be doing the annual ROI. I'll bring it in here so we can see it. Copy our question. And we'll leave a little space here for that. So what we're trying to do here is we're going to take the 95% confidence interval, right? And we want to use that box we talked about before, descriptive statistics, again, because we want to get the information that we already know about it. Okay? So we're going to develop a confidence interval for it based on the data here. Okay? And to do that, we use, let me bring that back, sorry. Come on, there we go. To do that, we use the data analysis tool pack. Okay. All right, go here, descriptive statistics, push OK. And we're going to highlight our input range, which is annual ROI. And we're going to say there's labels in there. We're going to put within the output range right here. And we're going to, instead of doing a summary, we're going to actually do a confidence level of the mean. Okay? And we're doing it confidence interval for the mean, 95%. So make sure that's checked and 95% here. Remember, last time we did summary statistics, we didn't care about that too much. Now we do, 95% confidence interval. You push OK. And actually, it didn't. You do need all this stuff. You could use all that if you wanted to. I think we do, though. I'm going to see, make sure we do not need it. Yeah, we need the mean. So yeah, we do need the mean. So I messed up on that. We do need the mean value. I'm going to go back there. And the one box I didn't check was right here. Go ahead and check it. It's going to ask you just to override it. Yes. So we're using these two values here. The mean. And I'm going to make mine orange so you can see it. And we also need the confidence interval. Guess what we do? We take the mean and we add and subtract the upper and lower from it. Is that hard? All right, so what I'm going to do is I'm going to bring this over here because I already had typed it up. Okay, so I want to go ahead and, for the lower limit, I'm going to subtract, and for the upper limit, I'm going to add. So what I'm doing is, I'm taking my the mean first, right? Take your mean equals the mean value. Okay, so for lower limit, you're subtracting. Is that right? Yep. And for the upper limit, we are going to add. So equals this plus the interval. Okay. And that is it. So I guess what your question is probably, how do we interpret this, right? Same way as the other one. You actually put something similar to this. Because we are 95% confident, right? That our annual ROI is going to be between 7.3 and 8.33. Okay. And that's because before we were selecting the the proportion of it, right? Now we're looking at the whole population, okay? If you look at the whole population, there's private and public. The other one here, we can't do that with this one. We have to actually run it on the whole data, right? The previous one, the previous scenario, we actually had a proportion of the population we had to do. That's why you need a z-value. We need to do the sample proportion, the coefficient, all that. That's why we do the other approach. Okay, so for this approach here, you're using the whole sample, the whole population mean, and you want to get the mean from the whole value and then do it this way. Okay, so this is this one here. Let's go on to the next one.